Okay, a CPU scheduling algorithm determines an order on for the execution of its scheduling process given in the n processes to be scheduled on one processes. How many possible different schedules are there? N factorial. 31 31 actually. N factorial, it's like n factorial things. Okay, the starvation free job scheduling policies and guarantees which are the no job definitely waits for the service. Which of the following job scheduling policies is not starvation free? It's round robin algorithm non preemptive like దాన్ని ఫస్ట్ కమ్ ఫస్ట్ సర్వ్ అంటారు. రౌండ్ రాబిన్ లాంగ్వేజ్ ఇస్ ఏ CPU scheduling algorithms where each process is assigned as a fixed time slot in a cyclic way, so each processes get a chance after a finite time. No job starves. Priority queuing, low priority jobs may starve. Low priority queuing, low priority ఉండేవి స్టార్ అవ్వచ్చు. shortest job first. Jobs having a long burst time may starve. Youngest job scheduling, jobs having least arrival time may starve. లీవ్ ఉండే యంగెస్ట్ జాబ్స్ అని అంటే ఏవి తక్కువ ఉంటాయి దానికి. సో లీస్ట్ టైం అరైవల్ టైం ఉండేది లైక్ స్టార్ అవ్వచ్చు. 32 the state of process after encounters in an input or output instruction is input output in a process after encounters input output instruction వచ్చేసి బ్లాక్డ్. ఇన్పుట్ అవుట్పుట్ ఇన్స్ట్రక్షన్స్ వచ్చే తర్వాత ఇన్పుట్ అవుట్పుట్ రిక్వెస్ట్ వచ్చిన తర్వాత అయ్యేది బ్లాక్డ్. ఏ ప్రాసెస్ ఆఫ్టర్ దట్ ఈస్ బ్లాక్డ్ ఆన్ సమ్ ఈవెంట్ సచ్ as input output operation completion or a signal may be blocked due to the various reasons such as exhausting its CPU time allocation or waiting for an event to occur. ఇక్కడ ఒక ఈవెంట్ టైం అక్కర్ అయినా ఏదైనా జరిగి బ్లాక్ అయినా రన్ అయ్యేటప్పుడు అది వచ్చి మళ్ళీ ఇన్పుట్ అవుట్పుట్ రిక్వెస్ట్ వచ్చేదాకా బ్లాక్ అవుతుంది. బ్లాక్ నుంచి సస్పెండ్ అయ్యి వెయిట్ అవుతుంది. లైక్ వెయిట్ నుంచి మళ్ళీ బ్లాక్లోకి రావచ్చు. ఇట్లా ఇక్కడే ఉండొచ్చు. వెయిట్ లేదా మళ్ళీ ఇక్కడ నుంచి సస్పెండెడ్ రెడీకి వెళ్ళి మళ్ళీ రెడీలోకి వెళ్ళి ఆ తర్వాత వెయిట్లోకి వస్తుంది. జనరల్గా ఇక్కడ వెయిట్ ఉంటుంది. రన్ నుంచి బ్లాక్ వచ్చి బ్లాక్ నుంచి రెడీకి వెళ్తుంది. తర్వాత 33 a particular parallel programming computation requires 100 seconds when executed is a single CPU. If the 20% of this computation is strictly sequential, then the theoretical the best possible elapsed time for this program running a 2 CPUs and 4 CPUs respectively are 60 and 40 seconds. 33 in two CPU systems, once 20% sequential instructions are executed in 20 seconds and the rest 80% can be executed parallelly by 2 CPUs, which can be done in 40 seconds time. So the total time for 2 CPU systems 20 plus 40 is equals to 60 seconds instead of 100 seconds. Similarly, for 4 CPUs minus 20% instructions can be executed in 20 seconds and remaining 80% instructions can be divided equally by 4 CPUs and can be completion in 20 seconds. So the total time for 4 CPU systems is equals to 20 plus 20 40 seconds. Like 34, which of the following strategies employed for overcoming the priority invention problem temporarily raising the priority of the lowest priority level process? Okay, 34. Priority inversion is a problem while priority inheritance is a solution. In other words, priority inversion means the priority of the task get inverted, and priority inheritance means the priority of the task get inherited. Both of these phenomena happen in a priority scheduling. Basically, in priority inversion, higher priority task H ends up waiting for a middle priority task M when H is sharing a critical section with the low priority task L, and L is already in a critical section. Effectively, H waiting for M results in inverted priority, and priority inversion of one of the solution for this problem is priority inheritance. In priority inheritance, when L is in critical section, L inherits priority of a H at a time when H starts pending for a critical sections. By doing so, M does not interrupt L and H does not wait for M to finish. Please note that inheritance of the priority is done temporarily. L goes back to its old priority when L comes out of the critical section. 34. Which of the following 35. Yeah, 35. The number of logical CPUs is a computer having two physical quad core chips with the hyper threading enabled is 16. 35. In hyper threading, every physical CPU corresponding to two logical CPU. There are two quad core chips, so total number of physical CPU is equals to 2 into 4, and 8 cores refers to 4. Now 8 physical CPU corresponding to 2 into 8 is equals to 16 logical CPUs. It is equals to 16. Which of the following is not a optimization criterion in the design of the CPU scheduling algorithm?